Hello, Physics Nation. My name is Nate Larmond, and I guess this is the third video in the series, How Does Distance Affect Acceleration and How Does Mass Affect Acceleration? I built a little ramp out of my notebook. I put my little toy car on it, and, it's back to Galileo. Galileo tried to define motion mathematically. He was the beginning of, kinematics, and really trying to find patterns in experimental data. So we're just following in his footsteps. He had a huge ramp and had little bells on the top, and the little wooden spheres would bing, bing, bing. He wanted the bells to be hit at a nice constant rhythm. We have a modern stopwatch, so your computer is a stopwatch. Your phone is a stopwatch. He did it with a pendulum, and like I said, this sort of crazy musical technique. Anyway, let's see how it turned out. I put in my times. I just actually listened to the YouTube video where I do the experiment that shows the methodology, and I put in my times. And this is how does distance affect acceleration. So I did 2 inches, 4 inches, 6 inches. And because I'm doing 2 experiments, maybe some color coding would be good. So there's experiment number 1. And, the cool thing about putting in the formulas before you put in the data is the data sort of auto-populates, like the calculated values come in as you put in the numbers. So, I don't know, it's kind of cool to watch the outcome occurring as you input the raw data. It's cool for me anyway. And then what I do, highlight, you can chop the significant figures. Yeah, that's fine. So here's part 2, how does mass affect acceleration? And I guess I'll color code this also. Yeah, that's good. I guess we can merge and center, right? Looks better. Hang on. Let's merge horizontally. Let's center this mess. Same deal here. Where'd it go? Let's horizontally align, and where's the merge button? Whoops. Here we go. Let's merge horizontally. Okay, so we have 2 questions, hence our 2 colors. And, the trend is fairly obvious. The distance isn't supposed to affect the acceleration, but it did. Let's see. Let's highlight X. Let's highlight Y. Insert chart. Not a column chart or bar chart. Yeah, there it is. As the distance increases from 5 centimeters to 15 centimeters, the acceleration is dropping. So that's interesting. I'm not sure how to comment on that. Let's add some titles and everything here. This is acceleration as a function of, as a function of distance. And this is distance. Independent variable is distance measured in meters. You just take inches and divide by 39.37 inches per meter. The vertical axis is acceleration in meters per second squared, or meters per second. And I'm going to fix my scale. Well, I guess I can do my trend line first. Is it linear? I don't know. Maybe not. Let's see how exponential looks. Well, let's see how polynomial looks. Yeah, I don't know. Like I said, the textbook says the distance isn't supposed to affect acceleration. But it's possible the faster this thing goes, the higher the friction is. Like, I really don't know. With fancy low friction carts and our little echolocation machine or photo gates or something like that, it's pretty convincing that distance has nothing to do with acceleration. Force is proportional to acceleration, not the distance traveled. So, sometimes things don't turn out the way the textbook says they're supposed to turn out. Let's fix the scale and then get out of here. Am I covering the scale? Yeah, so hit the horizontal axis and then go to minimum. I like 0. I think that looks better. All right, so there's graph number one. Looks like some kind of inverse relationship. The greater the distance, the lower the acceleration. So not a textbook result, but sometimes the real world is a little bit more complicated. Or maybe it's just due to uncertainty. Maybe I couldn't time the event. My ramp was itty bitty tiny. I mean, 5, 10, 15 centimeters is a really ridiculous distance. Galileo had a ramp that I don't even know was like 4 meters long. It was gigantic. Anyway, this is more of a qualitative data set. I could measure the mass of my car, I guess. Electronic scales are pretty cheap at Harbor Freight. But let's just do qualitative. Let's just do a bar graph. So I just did the car plus 2 quarters, 4 quarters, 6 quarters, and let's see how that affects acceleration. This is more of a textbook result. Sometimes it's hard to see a pattern in a data table, but I think I can see this pattern even before I draw the trend line. Let's insert a chart. Yeah, it's not the cleanest set. Sorry, let me get my face out of the way here. Customize, let's go to series. Let's check out this trend line. Yeah, it's pretty horizontal, and that's what the textbook says is supposed to happen. There isn't supposed to be any effect of the cart mass on the acceleration. It's like dropping, the wooden sphere and the steel sphere. They're both supposed to drop at the same rate. It's Galileo and the Leaning Tower of Pisa. So maybe a cleaner result this time. It's also interesting the way Google predicted the titles here. I'm comfortable with Google eavesdropping on everything I do because it learns. Some people are not comfortable with that. Whatever, as long as you understand their business model, accept the terms of the agreement. Thanks for watching, and see you in the next video.